Hey everyone, my name's Colt, and this is my little mini course, maybe not so mini course, on regular expressions. Really important topic. I get asked about it all the time, and it's great because it's not really language specific at all. It's its own topic that anyone can learn and then apply to Python or JavaScript or Java or whatever language. In other news, I did release a React course relatively recently, and if you want to take a look at that, you can find a coupon in the description for significant Udemy discount, as always. All right, let's get started. So the first thing I'll show you are the notes or the handout I made for this video. You can find the link in the description. I highly recommend you check it out. It includes exercises, fancy exercises. Actually, you can toggle the answer to show and hide, some tables, a bunch of cheat sheet references, and images and all that stuff. So let's get started with regular expressions. So the basic idea of a regular expression, let me zoom in a bit, or regex, as a lot of people say, and what I'll probably resort to saying in this video. The whole point of them is to help you match patterns within text or strings. And what's nice is that regular expressions, the syntax is almost uniform across all programming languages. So regex is sort of its own topic that exists on its own, and then is implemented across different languages. So I'm going to show how to use them within Python and JavaScript, but you can also use them with pretty much every commonly used programming language out there. So here's a simple problem to illustrate why you would want to use a regular expression. Imagine, we have a huge dump of text message data from our boyfriend or girlfriend's phone, and we want to go through and find every reference to a time. So something like this. Let's meet at 11:45, or I ran a 3:30 marathon. So that seems relatively simple, but if you think about how you would do that just using sort of string methods and looping, iteration, conditionals, it gets pretty complex because even with just time, it's not as simple as two numbers and then a colon and then two numbers. Those can't be any two numbers. We can't have something greater than 60 over here. And in this case, we can actually have one number, like 145, or two numbers, 1145, but we can't have 35 or 60 or some larger number. So we have to be careful. We have to make sure that we're matching a pattern with a valid time. In addition, what if we wanted to optionally check for seconds? So this could be valid, but we also want to allow for seconds. They don't have to be there, but if they are, we want to recognize it. This is a very simple example, but trust me, this would be very difficult and painful to implement without regular expressions. Lots of very messy, nested logic. So regular expressions help us define patterns like this that we can then find just defined or test if they exist, but also we can extract them. We can use regular expressions to help with searches, to replace or update text. There's a lot of things we can do. Just as an example of some really common formats that you can use regular expressions to help you with, email addresses, phone numbers. There are many ways of writing phone numbers, and this doesn't even account for country codes, but sometimes you put parens around the area code in the US, sometimes you use dashes, sometimes spaces, but this is also valid as a phone number, so we want to allow for all of those. Or passwords. We want at least 6 characters, one or more uppercase letter, one or more lowercase, one or more number, and one or more special character. So that's kind of difficult, and it's possible, but it's a huge pain to do on your own without regular expressions. All right, so we're going to dive into the actual syntax and learn this stuff. The first thing I want to point out is the link I included here next to this light bulb callout. This is one of many online editors for regular expressions. It's called Regexer, or Regexr, I think it's Regexer. Anyway, it's a live editor where you can type your regular expressions up here. We'll come back to the syntax, and then have some text down here that will be matched, hopefully, if you're doing it correctly, and it will show you the matches as you type them. So there are many of these tools out there, but I highly recommend you use it, or use one of them, because it's really easy just to make a mistake, and you want to see sort of a live result of what you're typing. So the next thing we need to talk about is the basic syntax. When we write regular expressions, we usually wrap them in these forward slashes. So these don't actually mean anything. You can think of it as like the quotation marks in a string. They are not really part of the string content. They are there to just denote this is a string. So I'm actually going to leave off those slashes in my notes. Like you'll see some of these regular expressions here, there are no forward slashes surrounding it. And the reason I did that is so that you can copy and paste them easily into Regexer, because if I zoom in here, you can see there are slashes there. I can't delete them. So whatever I type in here goes inside of those slashes automatically. Okay, so our very first simple regular expression is not going to be very useful. It's just the letter Z. So if we type the letter Z in a regular expression, all that it will match, the only pattern it's looking for, is an instance of the letter Z. So let's type a Z right here, and let's put some text in here, like this sentence: zebras say Z when they are dazed. And you can see we have some matches highlighted, the letter Z, and then 3 other letter Z's right here. Now these are all separate matches. So this is not one match, these are 3, and this is the 4th. Also notice the capital Z was not at all matched. If I change this to capital Z, we now have 1 match. If instead I type A, you can see what we get there. If I do something like a quotation mark, we're matching those. If I do HE, we have 2 matches. So this is 1, and that's the second. And I should note that you can't directly match every single character just as is. Some characters have special meanings. For example, a period or a dollar sign. And so we'll learn in just, well, not quite just a moment, but later in this video, we'll learn how to actually match a dollar sign instead of having the dollar sign mean something special, how to escape it. But first, we're going to take a look at a chunk of syntax, these symbols in regular expressions called character codes. So there's a table here with a bunch of examples. Let's start with the first one. So if we use square brackets and put some letters or numbers or something inside of those square brackets, it's going to match any of the included characters. So if we come back to this example, if I did uppercase Z, lowercase z inside of those square brackets, we now have, you can actually zoom out here and you can see 5 matches. So we have the 4 lowercase z's being matched and then 1 uppercase z. I can also, do something like this, A, E, I, O, U, and I'm now matching all the vowels. Each one is an individual match. We can also do the opposite. We can put this caret in front to negate that. So I can match anything that is not a vowel by adding that in right there. A, E, I, O, U. There we go. And if I wanted to expand on this, I could add in a second example. Let's do A, E, I, O, U. So this is going to match a non-vowel followed immediately by a vowel. So we get that right here, Z-E, R-A, S-A, and so on. So each one of these pairs is a match. Although you can also see we got this right here, a space followed by A. All that we said is not a vowel. We didn't actually specify it has to be a letter. We just said not a vowel. And also, we only specified not a lowercase vowel. So if we had an uppercase vowel, like this right here, it no longer matches. All right? The next set of characters is sort of a variation where we can use a range. If you can see that, A to Z will match any character within that range. But we're not limited just A to Z, but I can show you that here. If we did A to Z like that, we end up with a whole bunch of matches. Notice it is still case sensitive. I can do uppercase A to uppercase Z, and that will match any uppercase letters. I can also do uppercase A to Z, lowercase A to Z. I could do numbers. I could do 1 to 5. I don't have any numbers, but if I added them in here, 1, 2, or 1, 3, 6, 7, 1 and 2 are matching. So we can do a range. You can do ranges like, let's do F to P, and that will match letters that fall in that range. Next, we have the period, the dot. So this will match any character except for line breaks. So remember I said a period has a special meaning. If we were actually trying to match a period, this will match, but it's matching everything else as well. Every single character in here is matched, but if I added a line break, you can see that line break is not matched. Okay, next, a couple quick ones. We have /W. This will match any word character. So a word character is an uppercase letter, a lowercase letter, or a number, 0 through 9, a digit, or an underscore. So if I show you that right here, if we say word character, and then we follow it with a second word character. This is going to, actually, let's do a couple more. Let's do 5, 6 of them. This is going to match 6 character words. We only have one of them if we ignore this gibberish. So 1, 2, 3, 4, 5, 6. These don't match because they're shorter. A word character does not include a space. But remember, this also includes underscores. So if I did something like this, that is now a match. Because I put an underscore in there, it's not a letter, it's not a number, but it still counts as a word character. And same thing with numbers, I put them right there, and this matches as well. So that's \W. We have \D to get a numeric digit. So any numeric digit looks like this, just a single digit. So if I was trying to match 3-digit numbers, I could do this. Digit, digit, digit. And now we're finding 3-digit numbers. Now I could have written that like this, 1 or 0 through 9, and then done the same thing again, 0 through 9. And there's actually an even easier way of repeating something we'll see in a moment, but we're doing the same thing here. And then finally, we have \S, which will match any white space. So if I come back here, if I do \S, you can see one match, another match, and so on. If I had more spaces, like right here, those are all individual matches. So right now I'm getting 14 matches. So that's \S. All right, so it's now time for an exercise. Here it is. Given this regular expression right here, I hope you don't just copy and paste this and test it. Just try to do it. How many matches are going to be found in this string? And if you're doing this on your own, I recommend pausing it if you need to. Try and figure it out. And the answer is we are going to find 5 matches. What this regular expression does is it looks for any numeric digit, 0 through 9, immediately followed by a 1, 3, 5, 7, or 9. So this is going to give us 2-digit odd numbers. So we have how many of those? We have 5, 11, 13, 15, 17, and 19. And here it is in the editor. You can see 11, 13, 15, 17, 19, and 5 matches. Okay, so that was the first exercise. Next up, we have another group of special characters in a regular expression called, well, they don't really have a name, but I'm calling them quantifiers and more. So these help you specify a quantity of a character or of a sequence. So the first one is the plus sign. The plus sign will match one or more of whatever came before it. So in this example, we have A plus, uppercase A, and it is going to match anything where we have a single A or more A's. So let's do something like this. H followed by a lowercase a, and then one or more lowercase a's. And that will match ha, but it's also going to match ha, and so on. Now it won't match uppercase ha's, just lowercase. And it's only going to match one H. If I added H plus, A plus, now I can do something like that. So that's the plus sign. Next, we have star. So star will match 0 or more of the previous token. So you can see here, I have a color regular expression where the U has a star after it. So this means it will match 0 U's, 1, 2, 5, a million U's. Color is a match, color with a U is a match, and color with 3 U's is a match. So if I came back here and I change this to a star, we're now also going to match just H's because the A doesn't have to be there. It can be there, or there could be 10 A's. So let's change it to an H at the end like this, H star, and that means we'll now match ha like this, and so on. A lot of different ways of laughing. Next up, we've got curly braces. So if you specify a number inside of curly braces, it will match a specific quantity of whatever came before it. So let's, we can keep this for now. Delete this. And if I type lowercase a and then 5, this is going to match anywhere where we have 5 lowercase a's in a row. So I could have also just done A, like that, and that's the same thing. But we're not limited to single characters. I could do something like any digit, we want 3 of them. So then if I start typing numbers, I don't know, 1, 2, 1, 2, 3, 1, 2, 3, 4, something like that, any 3 digits in a row are matched. So that's the first version of the curly braces, but we can also specify a range. So if we pass in 2 numbers, like 1 and 3 over here, we will match whatever came before it, a letter A or a digit, will match between 1 and 3 of them. So if I come back over here, let's type a phone number. Let's see, 212-453-9999. So if I wanted to match each individual chunk of the phone number, I could say any number, any digit, 3 or 4 in a row. So now we have a group of 3, a group of 3, and a group of 4. So it is inclusive. So whatever number you put at the end there will be matched. We put 4, we got 4 in a row right here. We can also do a number and then a comma, which will match the specified number or greater. So if I had something like this and I wanted to match exclamation points and I wanted there to be 3 or more, I could do exclamation point, braces, 3, comma. And this just matches 3 or greater exclamation points. As you can see here, we have 1 match, and here we have a second match. This one did not match. Next up, we have the question mark. Now, question mark makes something optional. It means that we can match 1 or 0. So if we use this color example, so we have color, color with a U, and then color with a ton of U's. If we start our regular expression, so we want it to match color, so C-O-L-O, and then an R at the end, but the U is optional. If I just type this, we're only matching color directly. If I use a star, as we've seen, after the U, we match all 3. But if I only want these 2, I can change this to be a question mark. And that just says 0 U's or 1 U. So this is not in the running anymore. And lastly, we have the pipe. You've probably seen this before if you've done much coding. It's similar to the Boolean OR operator. So when we use the OR here, it matches whatever is to the left or to the right of the pipe character. So here I have some text, puppy, puppies, poppy, poppies, yuppie, yuppies. So all of them end with either PPY or PPIES. So if I wanted to match them, the entire word, all of these words, first, they all begin with some letter or multiple letters. It could be a Y, it could be a P. So I'm going to specify here some number of word characters. Now that does match all of them, but that would also match something like dogs, which maybe I don't want to match. I only want words that end with PY or PIES, the plural version. So some number of word characters, and then they all end with 2 P's, or they don't end, but they have 2 P's before the ending. And then we're going to add parentheses and say either a Y or IES. Now, the parentheses actually have an additional meaning that we'll see later in the course or in this video. Don't worry about it for now. Just know that they actually do something in addition to what we see here. But for now, they just allow us to make a decision, or for the regular expression to choose a Y or an IES. If I get rid of those parens, it's a bit different because now we're doing this entire thing or this IES. So you can see we're matching puppy and we're matching IES. But if I add those parens back in, now it's doing what we want. All right, so it's time for another exercise. Given this regular expression, O, it's not a 0, it's a lowercase o, question mark, K plus. How many matches are found in this string? You might want to reference this here, the charts. I wouldn't expect you to just remember all the syntax right now, but given this string, how many matches are found? All right, pause it, and here's the answer. We get 4 matches. So the pattern is that we're looking for an optional O, so 1 or 0 O's, and then any number of K's afterwards. So OK is a match, 1 O and 1 K. KK is a match. We don't need the O, it's optional. K is a match, and OK is a match as well. All right. Next, we're going to talk about a group called anchors. So this is a very short group. Two things, the caret and the dollar sign. So what these do is allow us to specify where in the text the regular expression should, or where the pattern should be found. So if I come back here, let's say that I want the word that we're matching, or this pattern, to only come at the very start of our text. I can add the caret at the very beginning. And this basically signifies the beginning of the string, or the beginning of a line. So none of these are matched because, yes, they might qualify for the rest of the pattern, but they don't actually come at the beginning of our string. So if I had, I love puppies, it doesn't work. If instead I change that to add a dollar sign at the end, the dollar sign means end of the string, or end of the line. As you can see here, you can hover, matches the end of the string. Now we get a match. And then the other thing that I can do is combine them together like this. And this says basically the entire string has to be a match. We have to have the beginning immediately followed by our pattern, immediately followed by the end. So now we could test, is this, if we were using JavaScript or Python or some language, we could check, is this entire string a match? Or if we didn't want that, we just wanted to know, does the whole string contain puppies somewhere inside of it? We wouldn't use those anchor characters. But if we want to make sure it's an exact match of the pattern and nothing else, then we can use the anchor characters. Okay, so next up, another exercise. Given this regular expression, I should say given, I'll fix that, hopefully, which of the following four choices contain a valid match? So pause the video, take a look. This combines a lot of what we've seen so far. All right, so what we have here is the beginning of the line anchor, and then an uppercase letter. We have a range, so any uppercase letter 2 times. So any 2 uppercase letters, then a space character. So that could be a space or a tab, something else, and then 5 number digits, 5 single digits in a row. That's what \d is. So this means 2 uppercase letters, a space, 5 numbers. And if we take a look at our examples, the first one does not match that because it has to come at the beginning of the string. So this has the pattern, but it's not at the right place. This one does not match because there's no space. We required a space. This one does match. It comes at the beginning of the string. It's also just the entire string. And this one matches as well at the beginning. As you can see here, this is not a match because we put the anchor character at the start. Next up, we'll quickly talk about escape characters. So as we've seen, a lot of characters have special meanings in regular expressions. The plus sign, question mark, all of these I've listed here. The star, the caret, the period, brackets. And if you needed to actually match them in your code or in a regular expression, you need to escape them using a backslash. So you can see this regex here. I'm matching a digit and then a plus sign. So if I actually just put the plus sign without the backslash, then it has its own meaning. The plus means 1 or more, or 1 or as many as you want. But if I want to actually match a plus sign, I need to use \plus. So if I wanted to match dollar amounts like 10, 50, or 99, 99, and have a dollar sign in front, let's say some of them have a dollar sign. Let's do 4, 25. And I want to match all of these. What I could do, if we delete this, we're going to have an optional dollar sign. So to type the dollar sign, it's \$ with a question mark. That makes it optional. And then we have 1 or more digits. So that's a plus sign because we might want a price of, 42222 like that. Then we're going to match a period, which we need a \, for because a period on its own means something else. And after that, we want exactly 2 digits, \d 2. So we could make it match a whole number like 50 instead of 50.00, but we won't worry about that for now. So if we didn't have the \$ and the \, period, it means something entirely different. So we do need to escape those. All right. One more exercise here. This one, I'm asking you to write something. So write a regular expression that matches an exponential expression like this. 4 to the second with a caret, 12 to the fifth, 3 to the 1122nd, and it should also work with negative numbers. So 5 to the -3 or -15 to the sixth. So it should be basically any number down here and then a caret and then any number afterwards. And it should also work with negative numbers. So give it a shot, pause the video, and here's the solution. So there's more than one way of doing this. Here's what I wrote. It looks like this. Let's bring it over here. I'm checking first for an optional negative sign with a question mark, and then one or more digits. And then we have to escape the caret. So let's do escape the caret. It sounds like my childhood at dinner. I do not like carrots. Okay, so here's what we have. Negative sign is optional. Let's put one on this one. And then one or more digits, then a caret that must be there, and then an optional negative sign, and then one or more digits. Now you could have also added in the anchors to see if a string only contains a single exponential expression. Mine is matching multiple in a given string, but if you add the actual caret in, not the escaped version, and a $sign, then it makes sure that the string is only a match and that there's no excess information or data. Next up, we have one more very important feature, a little bit of syntax, something called capture groups. So when I said earlier that parentheses also do something else, something in addition to what I showed you, this is what I was talking about. So if we return to this example, I'm going to paste it in. This was a regular expression that matches two uppercase letters. It's supposed to be a state code in the US, a state abbreviation, and then some zip code, which is, we're not actually checking, is this a valid state, right? There's no state that is ZS, but this still matches. And there may or may not be a zip code, 29837, but we're matching the pattern. And right now when I look at the match, we're just matching the whole thing, which makes sense. That's how it's been working so far. But if I was writing code where I wanted to extract the state and extract the zip code, maybe I wanted to figure out which state was making the most orders. So I went through all the addresses, I extract the state from every single one, and then I do some math. To do that, I mean, we could just take the match and then take the first two characters and do it with JavaScript or some language, but we can also separate them out using parentheses, using a capture group. So I wrap whatever I'm looking for, whatever I want to isolate. It's still part of the pattern. But now if I look, I have a group. You can see group number 1 at the bottom is CA, or this one is ZS. Let's change it to a valid state like New York. And then I can wrap the same thing here around the zip code portion. Now I don't want to include the space. Now I have group 1, New York, group 2 is zip code. So I've separated them out, but they still both have to be there. This is not a valid match if I just do CA. So this is very, very useful, as we'll see in just a moment when we talk about writing regular expressions and using them inside of a programming language. Often you're not just checking to see if a pattern is there, but you want to do something with it. You want to replace one part of it and keep the other parts the same. Maybe you have a huge data set and you want to go through and take all the capital text and change it to lowercase text. Or you want to find all of the addresses and you want to, like I said, extract the state, or you want to redact all the email addresses in a file. So you might have something like this, and you want to match all the emails. So this could be a valid email as well. And you want to hide the first part. So you want to find all of the emails, but then you want to replace the part before the @ sign with dashes or something, or anonymous. You could use regular expressions with capture groups, and you would put a capture group around the name here, like James, and you would remove that, but you still need to make sure you're matching this whole thing, because you have to know the context. We don't want to just replace any word. We want to replace the word that comes right before a whole email address. So that's where capture groups come in handy. So we're going to switch gears a little bit. We're going to write a larger regular expression, nothing crazy, but a little longer, which we'll use to help us find times, a 24-hour clock time format. So all of the following should match our pattern. We actually talked about this at the very beginning. Something simple like 2:45, or 2:45 with a leading 0, or 23, 23:50, and seconds. So it's not as simple as two numbers, a colon, and two numbers. It could be one number, a colon, and two numbers. It could be, hours, minutes, seconds. And we also want to make sure that we're only using valid times. So 2580 should not work. There's no 80 minutes. There's no 25th hour. So if you want to try this on your own, go ahead, pause the video. Otherwise, I'm going to show you my version. And there's more than one way of doing this. I'm honestly not great at writing regular expressions. I'm going to talk about this at the end. I usually recommend you just find pre-written ones by actual experts and people who know what they're doing, unless you're trying to match something that is very, very unique. All right, so here's my initial version. Let me just quickly walk through how it works. We have a couple different sections. The first bit is going to match a 0 or a 1 as the first digit, or a 0 through 9. Now, if it doesn't start with a 0 or a 1, we have the or, which means it has to start with a 2. We can't have 30 something as a time. We can have 00, 01, 09, or we can have 10, 19. But then once we hit 2, once we get to 20 something o'clock, we can only have 2 followed by 0, 1, 2, or 3. We have no 25 or 26 o'clock. So after that first group, then we have a colon. Then we have our minutes, So the minutes must start with a 0, 1, 2, 3, or 4, or 5, and then be followed by any digit. So we can't have 70 or 80 seconds or minutes. We have to have somewhere between 0 and 59. And then optionally, this whole thing is optional at the end. That's what the question mark means. We have a colon, and then the same exact pattern. 0 through 5 followed by 0 through 9. And so this is all working, as you can see here. We have a match. This matches. We can do 9:30. The problem we have right now is if I try and do something that is invalid, like 89:43, we're still getting a match. So what we could do that we've seen already is use an anchor to say this must come at the beginning of a string. But that might not be what we want. What if we want to match this? It is 2:45. Well, there's one other special character I haven't shown you, which is \b, and this is called a word boundary character. It matches, let's scroll over. It matches a word boundary position between a word character and a non-word character. So you can see now this doesn't match because earlier this was a match, but now we said it has to start with a word boundary, which means there must be a boundary here. It can't just be another letter. It can't be something like that or a number. It must be the start of a line or a space. All right, so I'm going to add that in, and we'll revisit the capture groups. Right now we have one group, which is around the hours portion. So this is a group, and then the colon is not in a group, and then we don't have a group here, so we could add parens right there. So now when we hover, we have group 1 is 23, group 2 is 50, but the problem is group 3. Group 3 is this whole thing, which we need those parens to make it all optional, and we need the colon to be optional. If we move the colon here, we now match things like this, but we would also match this as a time, which we don't want. So we need to say that the colon is optional, but we want a way to isolate this information right here. One option is probably, I think this will work, just put more parens in there. But now we end up with 4 groups. You can see we have group 1, group 2, and then group 3 is colon 32, and group 4 is 32. Well, we have one more option, which is something called a non-capturing group. Now this is going to look quite weird, but if we go in here at the beginning of this group and we add a question mark and then a colon, what this means is that these parens, this whole outer group, should not actually function as a capturing group. We just want those parens there to make the whole thing optional. We're trying to apply the question mark to all of this. And so the question mark colon means it's an optional group, or it's a non-capturing group. And then we need the second colon here to actually add the colon into the regular expression. And now if we take a look, we have 3 groups. There's no colon in the expression or in the group. We still have to match the colon, but it's not being captured. And there we go. This is working. All right, so this is a simple enough example. I'm sure someone will find an issue with it, which is great. There's at least one issue I've found so far with this regular expression. And this is kind of what makes regular expressions difficult, is accounting for all the edge cases, making sure you don't get any false positives, just fully testing them. And let me show you what I'm talking about. Here, if I have a valid time, like 12:45:36, this is matching, of course. If there's a letter at the beginning or another number at the beginning, it doesn't match. But if there's an extra number at the end, this is still matching. Or we could have this format, and this is not a valid time, the entire string here, or this entire chunk, but we're matching this part. So you might think you could fix this if we add a word boundary at the end, but as you can see here, it's still matching this first part. And also, if I add in extra numbers now, we're only matching this part. This is considered a word boundary in between those characters. So if you're up for it, try writing a better regular expression here that won't have these false positives, where we have numbers afterwards, or if we have extra colons, this is not valid, but it's still matching. And also, I'm curious to see if anyone else finds other issues. I'm sure there are some other problems. That always happens to me with regular expressions. Next, we're going to talk about how we use these in JavaScript and Python. So as I mentioned earlier, pretty much every programming language out there has support for regular expressions built in, out of the box. Sometimes you might need to import a module, like in the case of Python, and the method names might vary between languages, but the actual patterns you write, the syntax, the characters for the regular expression are very, very similar, if not identical. So you learn one syntax for the expressions and you can apply it in all sorts of languages. So we're going to start with JavaScript. JavaScript comes with a good amount, you might say a healthy amount, of regular expression methods. Here they are: exec, test, match, match all, search, replace, split. They all do, some of them actually do the same thing, but most of them do something different. We're just going to focus on the first 2, exec and test. But before we even see those methods, you need to know how you actually write a regular expression in JavaScript, how we tell JavaScript, hey, this is a regex. And it's nice and easy. We just write slashes. So if I wanted to make a regular expression variable, I already have this on my clipboard. This is not valid JavaScript, just to have a plain old regular expression like this. First, I'm going to make a variable. This is our time regular expression, but it's still not valid. I could wrap it in quotes, but the easiest thing to do is to wrap it in slashes. So on either side, I put a slash. And one quick note, I don't have time to go into this. You'll often see a G there. It's called the global modifier. If you are a JavaScript developer, I highly recommend you look into that. There's some weird quirks. The way it's implemented is pretty bizarre. But for now, this is it. Just slashes. We now have a valid regular expression. And we can start by using one of our methods. So if we look at the methods we have available, they're going to show up here. I might need to go down into the console. If I come down here, time, regular expression, here we go. We have a couple different methods. The one we're going to focus on first is called test. And what test does, it's a Boolean method, and it accepts a string, and it will return true or false. That's it. It won't tell us what the match was. It doesn't give us any information other than if the string contained a match. Now, this is useful if that's all you need to know, because it's a lighter weight method, it's faster. If you don't actually need to know the match information, you don't need to know, what time was matched, what are the hours, what are the minutes, what are the groups. If you just need a Boolean, this is easy. So we can put a time in here like 1:45, we get true. If I do something like, let's do 99:45, we get false. If I do, let's do 9:45 with 45 seconds, we get true. So that's pretty much it for test. You could write some logic, right? You could do if our time regular expression dot test some variable, some user input, something in our database. Then you can do something else, But next, I'm going to show you exec. So exec is a bit different. It actually returns the information, the matches that it finds. So if we do our time regular expression .exec, we pass in something with no match, it's easy, we get null. But if there is a match, if we did 4, let's do, how about 12, 40, 26. It returns an array. And this array has a couple of things in a very particular order. The first item is the entire match. The second item is the first group, the second group, and then our final group, the third group for seconds. So we could now extract the information we need out. If we needed the whole match, we would access the 0th item. But if I wanted to have the minutes or the hours, minutes, and seconds separated out, I now have them right here. So that's the very, very basics of regular expressions in JavaScript. Next, let's take a look at Python. So Python is a little bit different in that you actually have to include a module. It's a built-in module. You don't have to install it yourself. It comes with Python, but you do need to actually require it or import it. It's called RE for regular expression, and it has a bunch of methods that it includes. I'm just going to show a couple of them, or really just one, which is called search. But first, I need to show you how you write a regular expression in Python. So we can't just use the backslash or the forward slashes. We actually need to use a string. And you could do a regular Python string, but then that's a pain because some of these characters, like a backslash, is a special escape character in a Python string, and that gets very annoying to have to double escape things or triple escape them sometimes. So instead, we can use what's called an R string. It's just R, and then a single quote, and then our regular expression, and then the end of the quote. And this just tells Python, all right, don't touch this string. I want it as it is. Then once we've imported RE, we can run re.search and pass in our regular expression and then a test string. All right, so I opened the Python 3 REPL. I ran my code. Well, I imported regular expression, RE. I set up my time regular expression variable and a test string. Now I can actually test it. I can do RE, and the method I'm going to show you is search. There are many other methods included with RE, but search takes the regular expression pattern first, and then something to test it against. So I just did it on separate lines or separate variables to make this shorter. And what it returns is something called a match object. So this is different. This is different than JavaScript. The values that are returned, the name of the method. What this match object contains is match information, and I can access it, if we go back to the notes, by calling a method called group. So I need to save it to a variable. So let's do that now. Let's call it res equals, and then I can call res.group, and if I don't pass in a number, it gives me the entire match. So I passed in the string, it is 43047. If I do res.group with no value, just empty parens, I get the whole match. And the same thing if I do 0, as you can see here. But if I pass in 1, it gives me the first group, 2 is the second group, and 3 is the third group. So hours, minutes, and seconds. So another way of retrieving the group information, the capture group information, slightly different style between JavaScript and Python. Definitely, I prefer the Python version. The point is that we can use our same regex in JavaScript or Python. We can do the same things. We can get the groups. It's just different syntax. All right, so that's it for now. I know there's a lot that we covered here. It's pretty crazy. It's a big topic. The last couple things I want to touch on are topics I did not cover. So this was relatively comprehensive, but there are still some other topics and important syntax I did not talk about with regular expressions. If you want to take a look, first, numeric references. I didn't talk about that. Positive and negative lookarounds, substitutions, and flags. So there's probably more, but these are 4 of the more important topics I did not have time to cover. Lastly, I want to end on this note. If you are trying to use a regular expression to do something common, like matching an email or phone number, an address, credit card numbers, I highly recommend you do not try and write that yourself. Definitely go online and find an existing version. There are many, many blog posts and websites and resources where people can share regular expressions, comment, critique, upvote, that sort of thing. you don't want to have to create something very complex to match, let's say, a URL. And you don't want to have to rely on your own skills because it's really easy to mess up. So if you go to regexer.com, there's actually community patterns. And if we look at one, like let's say an email, if I can find email, if I can search here we go. Here's an email regular expression. Now typing this yourself is really annoying, and it's not even the matter of typing it, it's the knowing what is actually valid in an email, making sure you allow for all possibilities that are valid. So if I do colt@yahoo.com, that matches. I can do colt.cats@gmail.com, that matches. So anyway, the point is, don't try and write these on your own unless you're doing something that is relatively unique or simple. I highly recommend you just try and find an existing one. All right, thanks for watching. I hope you enjoyed it. Take a look at the notes. Let me know if you have any questions or feedback. And do the whole like, comment, subscribe thing if you have time for that. I appreciate it. All right, bye.